Second, I will introduce the test for protection CT. For this one, this is CT with primary is a hole. Primary side is a hole. When we conduct test on this CT, we connect secondary like this. This secondary. And for primary side, the two cable, one cable insert the hole from P1 to P2, and the second should be S1 to S2. For example, if this CT is a 5P10 and the radial body is 5VA, primary current for this CT is 200, second current 1 ampere. If we select the stop current, max test current means the stop current. Normally for 1 ampere CT, we use 1 ampere is okay. But if you say the cover does not enter the saturation, you can increase the test current from 1 ampere to 2 ampere to make the excitation test reach the saturation state. And if it is a 5P10, we select 5P. Bowden 5VA. Working Bowden 1.24. Accuracy limit factor you can find from the nameplate. If it's 5P10, here you should input 10. If it is 5P20, you should input 20 and here. Maximum primary fault current you can ignore this, or you can input the rated fault current. In the test mode, you can use default, stand test, or quick test. Stand test means cost more test time, but the resolution is high. Default means both resolution and the test time is medium. Quick test means test time is short, but the resolution is low. If we run test, first step is check connection. Second step is one unit system test. For one unit systems, the test current always be about 0.5 ampere. Third step is the gas. And then test ratiometer. Here is the power output voltage. Here is the inductive voltage from primary side. This is secondary side. This is the electric current. And then ratio angle measurement. For protection CT, the main purpose of test is to check the important voltage or the ring limit ARF value, means accuracy limit factor. The measured ARF value should be more than the nameplate ARF value, or the measured near port voltage should be more than the nameplate near point voltage. That means if the measured ARF is less than the nameplate ARF, if the fault current which is more than the ARF multiplied the rated current flow from this CT, the CT may be in the saturation state. Here is the measure, the excitation curve. Here is the near point voltage. Near point voltage should be more than the nameplate if it is listed on the nameplate of CT. And here is the ration test result. For protection CT, we just care about 100%. 100% current point. It should be less than 1%, and the phase angle less than 16 millionth. And the polarity, the measured polarity should be the same polarity. If you have connected S1, S2, and P1, P2, here we can find is reverse. That means we have made a wrong connection for the polarity. Winding resistance at the current temperature. This is the environment temperature when we conduct test. This is the temperature we transfer to 75-6 degree. And the evaluation result. If the measured ARF is more than the limb plate ARF, the result will be passed. Now we find for this CT, the measured ARF just 9.6. That means it does not comply with the requirement of limb plate 10. ARF is the most important factors for protection CT when we conduct test for protection CT. Second is the ratio and the phase angle should be comply with the standard requirement. Left side is the value we measured. Right side is the standard requirements from IC standard for the selected accuracy class 5P protection CT. Here is the excitation cover date. Here is the hysteresis loop of the CT core when it reached the saturation state.